So my name's Lance Fischer. I'm a software developer in town here, and Arduino, let me get a picture of it up here, is not so much software but hardware. It's if you've heard of open source software, like it's software that everybody can contribute to and anybody can use it and hack it and change it to make it however they want. This Arduino's like that for hardware. Like a lot of these hardware pieces that you'd buy at the store or whatever, they're like proprietary design, and you couldn't actually go build one yourself and sell it, or you couldn't really even build one yourself because you'd be infringing on their copyright. What Arduino is they've taken the idea of open source software and made some open source hardware. And so this is a very basic computer. It's a microcontroller. This is what the Arduino looks like. It's an 8-bit processor in here, and you can program it with C or C++. And there's a nice little programming environment you can download. It runs on Mac, it runs on Windows, it runs on Linux, and the board itself will give you analog inputs and outputs and digital inputs and outputs. And so what that means for you as an electronics tinkerer is that you can plug in like different sensors into the board and read the values from those sensors, like find out what temperature the room is, or find out if somebody's pushing a button or sliding a gauge. Any type of, there's like thousands of these electrical sensors, right?
Cameras,
you can plug
voice,
what?
Cameras,
Yeah,
voice.
yeah, like tons of, like any electronic gadget, you can plug it into this board and have like direct access to it. You can also output stuff from this board. Like if you wanted to control a servo to move a robot arm, you could do that with the Arduino. If you wanted to control a motor to spin some wheels on a remote control car, you could do that. Anything that you could wire up electrically, you could do very easily from the Arduino.
Is it a USB interface?
It is a USB interface. I actually have the cord here.
There are actually a number of options, but most of the newer boards have USB on them now. So.
Is this the same technology as those plug computers? You guys know?
No, plug computers are much more powerful.
Oh, okay.
Yeah, those are running like a
Orders
full
of
OS.
Okay.
Yeah, they're more like your tablets and stuff like that. They
Okay,
have
okay.
500 megahertz processor
Oh, yeah,
running
yeah, yeah.
Linux.
It's all loud and stuff.
This is like an old DOS box.
So if you were to start a project, how would you do it?
That's what we're going to do. We're going to build some stuff. And I think we can see everything on here. All right. So this is a nice little holder dealie here that's holding our Arduino. And then this right here is a breadboard, a prototyping breadboard. And if you've worked with electronics very much, it might be you'll already know exactly what this is and how it works. But this allows you to just like plug electrical components together really easily, and so you don't have to like solder wires and connect things with wires. You can just plug them into this breadboard. The way it's set up is you see this red line right here. All these pins that are vertical right along that red line are connected like by a wire below the board. And then the same thing goes with the blue line. All those wires along this vertical are connected. So if you plug something into this pin right here and something into this pin up here, they're connected. And then these pins in the center, they're connected horizontally. And you can kind of see, this is a clear breadboard, you can kind of see if you look at it where there's darker spots, that's where the wires can get connected. So let's jump right in to how do you program this thing. If you want to get started with Arduino, you can just go to the website. It's Arduino. If you just do a search for Arduino, it's like arduino.cc. It comes up. It's actually made by some guys in Italy.
Is CC Italy?
I
It's the Coconut Silence.
I think they chose it for Creative Commons, but people are hijacking those country code TLDs all the time.
I was about to
Maybe it should be. So this is the Arduino page. If you want to get started with it, you can just go to download and pull down the software. They have versions that run on Windows, Mac, and Linux. So I've actually ran it on both the Windows and the Mac. I haven't ran it on Linux, so I don't know how well that works, but people say it works great. So I've already downloaded and installed it. I'm just going to start up my Arduino environment. So this is a programming environment.
All the software open source?
Yeah, it's open source software. So this whole program here that allows you to program is open source software itself, which is pretty cool. And a lot of people who write these Arduino programs to do different things will open source that software too. So you can go to people are putting them up on GitHub now. A lot of people just share them with different file sharing stuff, but like a lot of the projects out are out on GitHub, which is pretty cool. All right, so I've got this Arduino sketch open. They call an Arduino program a sketch. It's kind of like the Arduino terminology. It's a program, it's a sketch. Because it makes it easier. Like they're all about being really easy. So I'm going to go ahead and plug in the Arduino. It's got a USB jack right here. So I'm just going to plug in this USB, and the USB will power it up. It powers the board off of USB, and it also allows it to communicate with your computer over USB. You can. What's that?
Blinking lights.
Yes, yeah. There's blinking lights. So
Open source.
yeah, that's open source right there. This is the power on indicator, and this right here is the LED that's built into the board. They just kind of give you a free electronic piece. So you get an LED built into the board. And we are going to make our first sketch. And actually, we don't even have to make our first sketch because they give you a bunch of examples packaged with the environment. So how many of you guys are like software developers? Like anybody, so you've built like a Hello World program before? The Hello World is like the first thing you build as a software developer when you're learning how to program. You make the program say hello world. Well, we don't have a display for the Arduino, so like the hello world of the electronics universe is a blinking LED. So we're going to do a blinking LED.
There are multi-billion-dollar pieces of hardware that come up in what we call Das Blinken Lights mode.
Yeah.
That's the first thing that you do is you blink a few LEDs. Does the hardware turn on? Does it start up? If the LED is blinking, you don't have bad silicon.
And it's plugged in.
Yeah.
So that means you could do Morse code, hello world.
Yes, you could.
Yes, you
yeah. But I don't know Morse code, so. All right. So after you get this installed, if you're running Windows 7, you'll have to do a couple of like security things in order to hook up the USB deal. They have that outlined in the getting started page on their website. If you run Mac OS, you can it just works, right? You just plug it in. We open up the Arduino, we're got programming environment, and there's an examples right underneath file, and we can go and pull up. They have tons of examples on here, which is pretty awesome. So we are going to go to basics and blink. We get the blink program for free. All right, I'm going to make this bigger. I don't know, can you guys read that okay? I bumped up the text size a little bit. So an Arduino program is like any other software program. It's code that gets turned into machine language that runs on this thing. The template that they give you to work with, and any Arduino program is going to look like this. It has two functions. One is a setup function, and the other is a loop function. So what happens when you power up this board, it runs to setup stuff once, and then it runs the loop continuously after that. So when we power up this, once we send this program to the board, when we power it up, it's going to run this setup function right here, and then it's going to run this stuff in the loop function. Go back up to the top, run the stuff in the loop function. It's going to keep doing that till you shut it off. And any Arduino program is going to look like that. Of course, the more complicated stuff gets a lot more complicated inside the loop, and sometimes more complicated inside the setup routine. So let's see. What we're doing here, this is in the Arduino programming language, which is based on C. In our setup routine, we are calling the pin mode function. What the pin mode function does is it assigns these pins on the Arduino right here. They're digital I/O pins. That means input output. So we need to tell the Arduino, are you going to use this pin for input, or are you going to use it for output? So we're assigning it. We're just making pin 13 an output pin. That's all we do. Then it goes down to the loop and starts running this stuff. And it does. We're doing a digital write to pin 13 with a high. That turns on pin 13. So whatever you have plugged into pin 13, it's going to get voltage at that point. Pin 13, what's that?
High being the most or on?
Yeah, because it's digital, right? It's either on or off. So
It's either
high.
gonna be 0 or 5 volts. So.
Yeah. After we write some voltage to pin 13, we're going to wait 1,000 milliseconds, or we're going to wait 1 second, and then we're going to write low to it, which says take away the voltage from that pin. And then after we've taken away the voltage, we're going to wait another second and then go back up to the top. So can anybody guess what that does? It makes pin 13 blink. And so this built-in LED on the board is actually hardwired to pin 13. So when we're talking pin 13, it means this LED on the board, or we can actually plug in something to pin 13. So we're just going to go ahead, and you can click this button here to verify it, and that means it compiles it.
Yeah.
I thought I saw it blinking already.
Well, it's because it's already been programmed. It's just running whatever was in there last. I actually need to close this tab here. All right. It was giving us an error because I had more code open than just that one page. Sorry about that. I don't know how that got saved in here. We'll talk more about Plex later. All right. Sorry. All right. We're gonna verify this blink. Make sure that it compiles. It tells us it's compiling. Done compiling. Okay. So that means that we don't have any syntax problems, like a missing semicolon or anything like that. We're going to upload it to the board. So what it's doing right now is it's taking that program, sending it over our USB cable, and rewriting what the program is doing on the Arduino. So we can see the LEDs blinking, which it was before because it was already programmed with an LED. But just to show you that it's working, we can make it blink faster. So we'll make it, instead of waiting 1 second, we'll wait 300 milliseconds between blinks. And we'll just go ahead and send that straight to the board. And after it programs the board, we should see a faster blinking LED. All right, that's success. All right, the end. No. So let's see. This is my box of components here, a bunch of electrical things, and we've got some LEDs. Let's take one of these and actually plug it together.
And how much do those packages go for when you buy it?
You can buy this whole kit that comes with a bunch of really cool sensors, and it comes with the Arduino and the solderless breadboard, USB cable, all the stuff you need to get started, plus a really good book about how to use it and stuff. And oh, there it is. This book right here, it's $100. You can get the Arduino itself, just this board, for about $32. So if you've already got some electrical stuff sitting at home, you know, you can get started for $30. But I'd recommend getting the kit because this book is very, very helpful.
It walks you through like stuff, step by step stuff like this to help you start to learn how to use it and what you can do with it, and it gives you all the parts to do that.
Yep.
So it's very, very helpful if you're just starting out and you're not really sure how to do it. You got an idea of something you want to do but don't know how. The startup kit that SparkFun sells is very, very good.
Yeah, I like it. That's how I got started, and I got started with this thing like 3 weeks ago. So,
So it comes with one USB interface that you can plug into your computer to control it, but does it come with additional USB interfaces that I can program to communicate with, USB devices?
So like if you wanted the Arduino to be a USB host and to actually take input from other USB devices, I'm not sure, but there may be, there are these things called shields that you can plug into the top of this Arduino. You can probably get a USB host shield that would enable you to do that stuff.
The only issue with the Arduino is that USB is an extremely heavy protocol, and actually the Arduino itself isn't talking USB. There's a little chip that you can see in that picture that's an FTDI USB to serial bridge, and then it's connected via serial line, regular serial port is all it is, to the actual Arduino chip, which is an Atmel chip. You can do USB host with it. It's only fast enough for like 1.0, 1.1, which is basically keyboards and mice, and even that's really, really pushing it. It's not designed around that. There are, once you get started with something like this, there are faster processors, and there are Arduino variants that have more memory and stuff like that, but they're still pretty speed limited. They're not very fast. You know, we tend to think in terms of processors today and the hundreds and hundreds of megahertz. Well, the fastest one of these runs 20 megahertz.
Right. Well, I don't know, maybe you guys are going to talk about this. Maybe that leads into like where this is headed. Because I mean, I just heard recently that Google chose Arduino as a hardware base for, interfacing with their Android platform.
Yeah.
So presumably, if that's the case, then I would expect Arduino boards to support, more powerful USB communication. Right?
That's not the thing about it is that's not the point at all of Arduino. It's to interface with the outside world, not with other computers. USB is a fine protocol for computers to interface with other devices, but it is a very extremely poor protocol for interfacing with the outside world. In fact, it's probably the worst thing that you could try to do because it's so complicated. You require a lot of memory, a lot of processing power, and a lot of speed just to say hi. In fact, there's 100 times more code involved in just the USB stuff to do the most basic talking to this Arduino than there would be in any Arduino project.
And I think where he's getting to is what you're saying is like how to interface with the Android. And the idea is you don't need the USB protocol to communicate. You can use Arduino code via the serial method to have your external devices communicate.
Yeah.
And the other thing, and Google announced at the same time, Android phones are going to be able to become a USB host. So instead of plugging Android into your laptop, you might plug Arduino into your Android, and that would be, that would provide its power.
Right, but the problem I see with like using, my Android phone is it as a USB host, it has a very limited number of connectors, so I was expecting that the Arduino platform would provide greater connectivity.
If you want to connect to other USB devices, you buy a $5, $10 USB hub.
You guys maybe can offer some input on, to what degree did Google's announcement about the Arduino platform, exactly how is it going to be implemented? Because I guess I don't fully understand.
So, like, you know, you buy a mobile phone, it comes with all these good sensors built into it. It has, like, an accelerometer, it has GPS and stuff like that. But for some applications, those sensors might be not exactly what you need. You might need a different type of sensor. Like, maybe you want a sensor that senses radiation or something like that. You could build that radiation sensor on the Arduino platform and then plug it into your phone, and your phone now has a new sensor. So it's kind of like giving your phone more capabilities.
And I think they also announced by, like, do you know the Zigbee standard for home automation? There's like a type of communication that was created for low power devices to be able to communicate throughout a house. So you could, with the Arduino platform, hook an Arduino board up to your lights in line with the circuit and hook one up to your phone. And when you send a communication through Wi-Fi or this, then you can do home automation with that. So the reason Arduino is so cool is if you want to build a temperature sensor, you can build 50 of those boards that just sense the temperature and then send it out. And then you can build a collector on your phone that will collect it, send it to your Android, and then you can build an app on your Android that will tell you the temperature of everything in your house.
I like it.
Yeah.
Yeah, and there's actually already other apps out there, Domotic Home with Arduino, that will take care of everything in your house already.
Cool.
The open source Arduino community was very quick to jump on that capability. And what Google basically provided is just a way to use the phone as a USB host or program the Arduino devices, upload code to them like we're doing now with the sketchbooks and stuff like that, but also a set of basic utilities for getting data into and outside of the real world, which is not generally USB. It's push buttons, it's toggle switches, it's infrared sensors, it's ultrasound sensors, it's your infrared remote control for your TV, you know, those sorts of things. And that's what Arduino is targeted at connecting with, not other USB devices. It's that's you know, USB, like I said, is just much more complicated than what Arduino needs for what it wants to do and what it's trying to do, which is to interface in the real world in probably a simpler manner, is what I would say, is what I would call it, honestly. I mean, compared to, you know, trying to write your own USB driver, which then you've got to write it for like Windows, Linux, Mac.
I guess the question I have, though, I mean, someone here mentioned the Linux plug devices, and they're not, at this point, a whole lot more expensive, you know, than Arduino. So I'm wondering, at some point, are we going to just see, you know, the whole hardware capability, you know, for this very low price platform just move up to where you can expect to have a whole Linux operating system running on your embedded devices?
You might see that, but there's a couple of reasons you might not. The Arduino is a prototyping platform. So what you can do is it has a set diagram for this, a set schematic for the circuitry on here. You can prototype your new hardware device, your new cool thing, right, on the Arduino, build it, and then once you have it all prototyped here, that's not how you're going to ship it and sell it. If you wanted to sell something, you could take that same componentry and then have it built into a custom PCB that you'd send off and have manufactured for very cheap, with a lot cheaper components that take a lot less power than a plug computer.
Actually, a really good example that just occurred to me. The Motorola Zoom uses an Atmega as part of its control subsystem to turn the power on and off. So it's part of its power control system. It also helps it to interface with the capacitive touch screen. It uses Q-Touch, I believe, by Atmel system. So the Arduino is like a real-world bridge for things like a plug computer. The plug computer itself, like those, they don't have as many simple I/Os. They have like maybe 4. Because they're designed more around talking Ethernet and TCP/IP and, you know, SATA and stuff like that, things that need huge storage and big disks and stuff like that. But you'd use a plug computer to, say, aggregate the 50-odd temperature sensors or power sensors that you have in your home. It would collect all the data, you know, from the Zigbee wireless network or whatever, and, you know, present a web page for it. So there's a space for both of them. They're really complementary to each other. Is I guess what I'm getting at there.
So my brother works for a company that aims sonars under the piers of bridges in remote areas, And then that bounces back to see if the ground underneath the piers on the bridges is washing out, because that's kind of a danger when your bridge breaks. And, and one of the sensors, all it does is check the batteries on those sonars. And this would be a perfect, situation for that, because he's trying to figure out what kind of board to use. He solders all his own boards.
Yeah.
Yeah.
And it's like, this sounds...
He could
something-
prototype it very easily with this. I mean,
Yeah.
especially if he has the skills to solder his own boards.
Yeah, well, that's what he does for work. He worked for
Yeah.
Intel. And, anyways, yeah, that's cool.
Should we build some more stuff with it?
Yeah.
All right. So we're blinking an LED, and so we got that success. We're gonna move up and actually plug in something to the board. So let's blink an external LED. I know it's a small step, but one other point I wanted to make is that once you program this, once you write the software in here and then click this button to upload it to the board, it doesn't have to be connected to your computer anymore. It runs on its own. So I'm gonna unplug it. It doesn't have any power, but if we plug it in to this regular old power outlet, the board's gonna power up, run that setup routine, and then start blinking again. It's not relying on a computer for that. It's its own little computer.
So it has a memory board in there or something?
It has this right here. Oh, you can't see it, but it has a it has this.
Inside of the main chip, there's
It's inside of this microcontroller here.
Oh, okay.
Yeah.
And so is there limitations on that?
As far as how much memory and yeah, there are definitely limitations on that.
How much RAM does it have?
I don't know which one that they're using. It's going to be it's less than a kilobyte.
Yeah.
But you can do a lot with that, because remember, you're working with an 8-bit processor. To represent that LED blinking, that's 1 bit that's being toggled on and off. The entire program, I can't see it, but I imagine it's a kilobyte. 32K of flash,
Yeah.
but not RAM. Your RAM's going to be, like I said, less than a kilobyte.
Yeah.
So I don't know specifically. I don't remember. I haven't looked at them closely enough, so I can look it up.
But it's got a lot for what you are going to typically be doing with it. If you're just writing things to control things in the real world, I haven't ran into it yet, but I haven't made anything super complicated, like a quadricopter or something like that.
Yeah.
Which people are making
Yeah.
quadricopters that are self-flying, like drones, which I'll show you video of that. It's super
It's cool.
cool.
It's so freaking cool. I want one so badly.
Is it low power consumption?
Yeah, they're low. I mean, as low as they can be. It actually uses the big brother for the Arduino. Let's see.
For the Atmega chip, they come in what they call Pico Power versions, which can run for a year on a AA battery. So they can be very, very low power, assuming that you're willing to also take some concessions in terms of their speed, which if you're looking for low power, a lot of times you're just looking to wake up once every few minutes, check a temperature, and go back to sleep.
That's pretty good. 1 year?
Yeah, they can last a very, very long time on regular 1,000 milliamp hour AA. So.
That's an example of what you can build with an Arduino.
And that's obviously with a stripped down non-prototype board. These prototype boards take a lot more power because they've got a lot more stuff on them.
This the one they built this one with is actually a little bit bigger board than this Arduino. It has a little bit more processing power on
Probably
it.
the Mega 2560.
Yeah, it's the yeah. But this one has a GPS built into it, and it can fly to a position and hold that position with the and transmit video back. So if the wind blows it, since it has GPS, it flies back to that position.
So I imagine developing a program to do that. Or do they have some good debugging software?
The debugging's kind of rudimentary on it, but
I'm almost going to hard work on that. I'm pretty sick.
Super stable.
But the cool thing with Arduino is there's a lot of software libraries out there that you can just go grab one of these libraries and start doing stuff with it. So this whole Arducopter, they have a library that they publish that you can just download the Arducopter library and run it and access to Arducopter programs to right from your main program to like it makes it very easy to hack and modify. They're just doing some GPS position holding
And
there.
we'll take how many millions or billions for the predators and stuff like that, you know?
These are the homemade version. And this is video feed from the from the yeah.
Is he using like a GoPro HD or what is he using?
They have another shield plugged in for video stuff, and then they have a Zigbee that they're using for the actual controlling it. You can buy an Arducopter kit. I think they're like $300.
Really?
Yeah.
That's not bad at all.
All right. So we'll get back. We're not going to build one of those today, but that'd be super sweet if we did. All right, we're going to start with getting an LED on here. So we'll move quickly so we can get to a couple cool things. You see this LED? This has one long leg on here. With an LED, the long leg is positive. Not everything has polarity, like all these electrical components, but LEDs are one that you have to plug in the right way. So I'm going to plug it in with this longer leg on the top. We'll plug it into pin 10 or pin 10 and 11 here. I don't know how. Can you see that? Yeah. So we're going to plug it into our. It's kind of hard to get in here sometimes.
There's also, if you happen to have an LED with the leads clipped off, they usually have a flat spot on one side that denotes which side is the positive too. I don't know if these ones do, but
yeah, you can if you look at them on the side.
The bottom, you can generally see, or it's easier to feel it. I've always found, but there's usually a flat spot if you don't actually have the length, the long. They've been clipped off for some reason. So
this is it's a 10K resistor, and a resistor like kind of slows down the flow of electricity, and it doesn't matter if you which way you plug this in. So we're going to plug that resistor in to the bottom pin and then connect it over to our negative power rail.
You can think of resistors as a smaller sized pipe, and voltage you can think of as pressure, and so a resistor lowers the amount of water or power flowing through it, and you can also lower the voltage on the other side as well.
So, let's see. We've got this right here with the blue line down it. That's typically known as your ground power, your ground rail. Like when you're prototyping, you'll always hook up your ground to that. And the Arduino here. Let me move this sketch out of the way. If you look at these pins, you can kind of see them up there, but it has a couple places for ground built into it. So that just lets you take ground off the board here. Plug that into the ground, and we plug the ground into our ground rail there. And then most people will power up their power rail here. It's a 5-volt rail. And you take that off of the Arduino board here too. Probably can't see it too well in there, but that where I just plugged it in is labeled 5V on there. And then, so now our LED is hooked up to the negative power rail, but we are going to want to control what it's on and off based on pin 13, right? So we're going to actually tap off of where it's plugged into here on 10. That's plugged in right next to it, so it's connected to the longer leg. And we're going to, actually I'm going to power down the board here.
Is there a possibility to fry the board if you don't know what you're doing?
Yeah, but it's hard to do.
They're pretty robust.
Okay.
Yeah.
You certainly aren't going to plug in like a regular incandescent lamp into one of these things. That'll cook the processor, but well, not necessarily, but that can cook the processor. They're pretty robust. They're designed with Atmel designed with prototyping in mind, so they're pretty hard to kill. But you do have to keep that in mind. You don't want to plug it directly into 120 volts and put a 120 volt live wire into one of the inputs. It'll just cook it.
When you say Atmel, isn't that a mail client server? Or
No,
what? I mean,
ATMEL.
Okay.
That's the company that makes
okay.
the actual processor that the Arduinos
Okay.
use.
They're super popular.
They make a huge range of embedded processors. I guarantee you have probably, if you have any sort of electronic device, you probably got at least 2 of them.
Wow.
They're in everything. They're in your cars. They're in everything. Even if they're not the main processor, they're doing something.
So this is pin 13 right here. Rather than powering that built-in LED, we can plug in our LED into pin 13. And the only reason we needed to put that resistor in is so it didn't blow up or blow out this LED. Like they'll get fried if you put too much through them. But we don't even have to reprogram it. We can just plug it in here, and we should get our flashing program running on the LED. Pretty cool.
Catch every flash.
All right. So I mentioned this kit from SparkFun before. It's pretty cool because it comes with all these little cards, and I'll throw them under the camera here too. So it comes with these. I'm gonna unplug. If you can kind of see that, it comes with these cards here that like show you how to do these basic circuits. So this is the one that I just did, plugging in that LED into pin 13. In the book, if you follow along, there's a lot of other projects you can build. Like this one's a lot of LEDs, like 9 and then this project here, it's got this. I don't know what that one is, but this one here is a servo motor. You can plug a servo in and then control like where the arm moves on that servo. This project is even more LEDs. You can build more than flashing LEDs with this, just so you know.
Does it have A to D converters?
A what?
Does it have A to D converters?
Yes, it does have several built in. That's the analog pins he was talking about earlier. It does have, I think there's 4 on that one.
We get 6 analog
6
inputs here,
analog.
and what analog inputs do is if you have something like a potentiometer, so this little deal here is a potentiometer. It's a dial that, as you turn it, it varies the amount of resistance. So if you plug this dial in and wire it up to one of these analog pins, you can read the amount of voltage that is coming to that pin, which varies based on how much resistance your potentiometer is putting in. The board, the Arduino board will translate that value into a number that you can work with. So it'll say, if you're varying the resistance on your potentiometer, you're going to get a number out of that analog pin that's somewhere between 50 and 600. And then you can do different things based on that. So like a temperature sensor, you're going to get different voltages out of that. It might range between 50 and 500. And just by looking at the specs for that temperature sensor, that, 400 means that it's 150 degrees, or like 200 means that it's 62 degrees.
There's tutorials out there on the formulas that you need and things like that in order to convert those numbers into actual Fahrenheit and Celsius measurements, because they don't, they obviously, 401 is not necessarily 1 degree hotter or colder, and there's, like I said, there's tutorials how to use them and stuff like that are freely available in the Arduino wiki and stuff like that too, and on SparkFun and other similar sites.
So we can build one of these cooler little circuits right from the book. this one is, it uses a potentiometer. That's this box right here. And it goes into analog 0. So the reading that you get from that analog 0 pin is going to be a different value based on where the potentiometer is set. And then the other thing that this has is, it looks like that's an LED right here. So I think if we load up that program, it's going to vary the brightness of that LED based on how much you turn the potentiometer. So let's go ahead and build that one really quick. The way that this is kind of designed that you can like plop this on the board and then just plug straight through this this paper, but we're not going to do that. We'll just plug it straight, this stuff into the board. So let's see. We've got our LED plugged into pin 9. Let's take our potentiometer and plug it in. I don't know what they have it in, but we'll just plug it in here, 6, 7, and 8 on this board. So there's three leads on this. The top one needs to go to negative, the bottom one needs to go to positive, and the middle one goes to our analog pin. So we'll just put that here. I'm going to throw it right at the very top of the board. My video is a little bit off, but that's fine. Let me grab a few wires out of here. I'm running low on black wires. I should have brought more. So top of that one, we'll connect it to ground, and the bottom of that one, we're going to connect that to our positive power rail. It doesn't matter where you put it. And then the middle one part of that potentiometer, if I can get it in there. Okay. I did an
Electronics
orange.
is obviously not a hobby if you have very large hands.
Yeah. You have to get a custom big breadboard.
Yeah.
I'm going to plug this into analog 0. All right. Let's go open up our Arduino environment here again. So the circuit I'm working off of, this template here, that's called Circ 08, and that's in our book here from Spark Fun. And they show you like all the code that you need to write in to your program. You can also just download it from the internet, but we can just do a little bit of yeah, we can download that thing. Oh, actually, we get this one for free in the examples. Let's see, examples, and then analog input. All right. So let's see what's going on in this program here. We got our potentiometer plugged in. Our goal is to control that LED with it. So our LED, they have some variables created here. They're saying that the LED pin is defined as pin 13, which is good, and the sensor pin, which is our potentiometer, is A0. So in our setup, we're going to set up the pin mode for the LED pin. Remember, we have to tell it that LED, that pin 13 is an output, and then it's going to go ahead and run our loop here. It does an analog read off of the sensor pin, which will give us the value of that potentiometer just as a number, and then it's going to, oh, this is what it does. It's going to turn on the LED, and then it's going to wait based on the sensor value that we read in, and then it's going to turn it off and it's going to wait based on the sensor value that we get from the potentiometer. So as we turn this dial right here, it should slow down how fast our blinks are happening. And we've already got it hooked up to pin 0. It should be ready to program. All right, so it's powered it up, and it's running our old program still. So we're going to go ahead and upload this program to the board. All right, it's done uploading. Let's see if it actually works. We'll turn this little potentiometer.
Woo!
Yeah. And if you make it go fast enough, it just stays on.
Well, it appears to stay on.
Yeah, I mean,
Right.
it's flashing here, but you can't
Yeah,
see
it's
it.
the frame rate's real
That's
low
cool.
there.
Yeah.
That's really cool.
Have you used your Arduino to make any projects at home?
Well, I did make this robotic Plex toy from foam board. My son likes that. I have a 3-year-old son. He likes playing with this Plex thing. Of course, it's not very durable, so I kind of have to supervise. But I have plans to do all kinds of things
I think that's the one thing that everyone in here has in common. Evil plans.
Yeah. I want to control my garage door opener with a phone call, and
It's
it's
totally doable.
possible. Yeah, I have.
They sell, well, I don't know if it's a Shield, but there's components to make phone interfaces with, touch tone.
I've already hooked up the phone to it.
Already started that part.
Yeah, this right here is a Wi-Fi shield. You can take this shield and plug it into those pins on your Arduino, and your Arduino can talk over a wireless network. It can act as a web client, or it can act as a web server. So I've built a very basic web server out of my Arduino that
They have Ethernet ones too.
I think $60 or something. Yeah.
Effect with 3 users.
Yeah. No, I think it'll crash if you refresh the page too fast.
Obviously, the solution is to set up a cluster of them.
Yes.
Yeah, but I've seen it.
Then our potato power,
So do you guys want to power up the Plex robot?
Yeah.
All right. So has anybody in here
The
watched?
frame rate's just a little off. It looks
Yeah,
like
it's making beats.
dimming.
I really like that.
Yeah. It's like a strobe light.
Yeah, it looks like it's
effect.
dimming and coming back when it's actually blinking.
Anybody here a Yo Gabba Gabba fan? Anybody watch that show? Probably not. If you don't. It's on Nickelodeon.
That explains all.
Yeah, it's a pretty good show actually. It's DJ Lance is the host, which I kind of dig. The Aquabats made it. They're a performance art ska band. Anyways, we're gonna plug our Plex in. So can you guys see this thing all right? What I have right here is a servo. And the cool thing with the servo, a motor, an electric motor, you put power to it and it just spins and spins and spins. A servo, it has a little bit of electronics built into it. You can write different voltages to it, and based on how much voltage is sent to that servo, it moves the arm of the servo to a different position. So if you are writing a low voltage to it, the arm might be up here. But as you start to write a higher voltage, it'll move down here. So you can control the exact position of that servo arm based on how much voltage you're writing to
There
it.
are libraries in Arduino to do all of that for you. Because it's actually a little more complicated than that. It's actually the width of the pulses that it's tracking.
Well, that's what those analog pins are actually. They're not true analog, they're pulse width modulated pins, which is a little bit more technical electronic stuff. But this LED right here, that we're flashing it. If I move it really fast, it now looks really dim. What's actually happening is it's still flashing it, but it's flashing it so quickly that you can't actually, with your eye, pick up that it's flashing. So it just looks dimmer. And that's kind of like what the pulse width modulation is that it's writing like on or off values at a specific like frame rate. So you get a simulated like analog. And that's what's happening with all these analog pins here. So when we actually write a low voltage to to our servo to control Plex's arm, we're kind of like doing a slow frame rate or a fast frame rate based on how much voltage we're setting. The other feature that Plex has built into him is an LED on top of his head. We can light that up or turn it off with our digital I/O pins. So I have a cool Plex program that I wrote that I'm just going to load up. It lets Plex do a couple neat things.
Is Plex the library?
I did not make it a library. I just made it a program. But
What do you mean by Plex?
that's the name of this robot.
Oh.
Sorry. This is Plex from Yo Gabba Gabba.
Everybody, Plex, everybody.
Yeah. Sorry if that's
Plex
clear to
also
me.
talks about
'Cause-
himself in the third person.
Yeah.
Sorry.
You made that entirely on your own versus like having a library that's like meant to have a cardboard cutout.
Exactly. Yes, I made this Plex program, but if I wanted to go to the next level and sell these Plex robots, I could or just give them away. I could give people plans to cut them out of foam core and hook up a servo here and a light here, and then I could also provide this library. That's the Plex library that you can say move arm 10 degrees, and the library handles changing the numbers around for you to do that, or turn on Plex's light on his head, and the library would handle doing that stuff for you. So you didn't have to know quite at a low level I need to write the value 300 to the servo pin. You would just know that you wanted to move Plex's arm, and this is kind of coming apart, but all right. Well, let's open up our Plex program. I have it in my projects, Arduino. I've got Plex. All right, Plex. Okay, here's our Plex program. It's a little bit more complicated than these blinking LEDs we've been looking at. I've tried to pull out stuff into variables so we actually know where to plug pieces of Plex in, because there are 5 wires to Plex that we need to plug in. These 3 wires control the servo, and these 2 wires control the LED on his head. So let's unplug this. And I'm going to pull out this yellow LED here. Actually, it works better if you make sound effects while you do it. And in place of that yellow LED, since we already had our resistor set up in there, I'm going to plug in Plex's hat LED right in here. If I get the right pins.
Tweezers would probably help.
Yeah, you get. I mean, if you're not presenting, it's easier to do this for some reason. All right, we got those plugged in, and then we're gonna plug in these servo wires. We've got with the servo, we've got these 3. We've got red, white, and black. So positive, negative, and then this. This one is going to go to one of our analog pins so we can write different values to it. I'm going to plug these just into this rail down here so they're a little bit out of the way. And then this one, let's look at our sketch to see where we're supposed to plug in that servo pin. So servo pin goes into pin 9, which I take back what I said about only having 6 analog pins. We have 10 analog pins. Well, we've got more.
A bunch of them are shared.
Yeah.
And for a servo, you don't need an analog pin. You just need a digital pin.
Is there a proper DAC on it though to do an actual
variable
Yes.
output?
Yes, you can build one. The variable output though requires extra circuitry on the outside. You have to, in order to get away from a pulse width modulation, you have to build a capacitor resistor circuit in order to get a smooth waveform out of it. But you can do it. At the heart of every CD player, that's exactly what they do too. And then they amplify that smoothed out waveform.
Are there any simple shell or console programs where you can interactively like write values to pin, voltages to pins?
Yeah, there are. There's a couple cool things about that allow you to like directly control the Arduino from your computer. Like there's a processing library that kind of have a set sketch that you program the board with, and then it allows you to interact with the board over your serial port with this processing language on your computer, which a lot of people will use that if they just want to hook up some type of internet active environment straight to their computer, like maybe a store display or something like that. There's this other software. It's called Node.js. It lets you run JavaScript as a server. And there's a package for Node.js that you can install that lets Node.js talk over the serial port, and then you can do anything you want over the serial port with Node.js. So you can hook up your web server if you build your web server with Node.js to your Arduino through your computer, which is kind of a cool way to do it. I saw these guys down at the Node.js conference a couple weeks ago, and they hooked up an Arduino with a soft potentiometer. It's just I have one here. It's like a potentiometer, but it's a touchpad that you push back and forth with your finger. They hooked that up to the computer, to Node.js, which they served out over the internet into a browser that they had running. With the browser had a connection to Node.js with a library called Socket.io that lets you keep a connection open for a long time. And then in the browser, they had a YouTube video that they were controlling the position of that video with a library called Popcorn.js from the value that originally came from this soft potentiometer. So they open this browser anywhere, and they could scrub through the video by using the soft potentiometer. It's pretty neat stuff. I mean, like, there's not a lot of that's not a practical application, but there are practical applications that use that type of technology. And I don't think we'll have time to show more, but I have the Wi-Fi shield hooked up, and it's serving a web page that this service called Twilio understands. And so you can call a phone number, and Twilio is this web service that answers the phone and then makes a call to whatever web page you tell it to, which in my case is this Arduino. And the Arduino sends out this web page, XML back to Twilio that has all the values of our sensors in there, and then Twilio reads that back over the telephone. So, like once you get this thing turned on and hooked up to wireless internet, you can call Twilio and it'll answer and say, "I am an Arduino. Analog pin value 0 is 238. Analog pin value 2, like it just does that." But like my ultimate goal is to open the garage door with that.
Couldn't you have it say, "Would you like to open the garage door? Press 1."
Yes, you could. That's my plan.
Turn off the kitchen lights.
Yes, you could do all that, and you could have it
turn on the stereo.
To find out if the garage door is open, press 3. All right, so we got Plex. I'm creating a servo object, which is included from this servo library that Michael was talking about. And it allows you to easily control these servos. I'm saying that servo is hooked up to pin 9, so let's actually just do that really quickly. I already hooked it up to pin 9, so that's this gray one hooked up to pin 9. And we've got this potentiometer pin is hooked up to pin 0, which from our potentiometer demo, it's already hooked up. Wow. And then these values here are just a couple variables that help me control what I expect out of that potentiometer. So from this potentiometer, I'm expecting values between 60 and 700. And then the servo, I'm expecting, servo, I'm expecting to write values between 0 and 179, which that correlates to the angle of his arm between 180 degrees. This particular servo moves from 0 to 180 degrees.
And old school joysticks like you had on arcade consoles and stuff like that, that's what a lot of them have inside them, is just potentiometers. You're controlling the resistance, and when the computer reads that resistance value, turns it into a number, and that decides, well, you push the stick slightly right, slightly left, a little up, a little down, whatever, stuff like that. So
Uppercut.
yeah.
We could hook up a joystick to control our Plex robot.
He's got an older style one.
You could
Most
use
of the
your
new
little
ones
dial
don't
to
anymore.
make his arm go a certain.
That's what we're gonna do.
Oh, sweet.
Yeah.
Sweet.
All right. So
It's a little slow.
we got a setup routine here, and this is initiating our serial port. So this is kind of the way that you debug Arduino programs, is you write values out to your serial port. It's like if you do old school programming, like doing print lines, but there's no like display to run print lines to, so it's printing stuff out to the serial port, which we can view with our Arduino IDE here. Integrated Development Environment is IDE. And then so our servo object was provided by that library. We're attaching it to our servo pin, which was pin 9, right? Then we're setting up the pin modes on our LEDs. We set the LED pin, which is pin 13, as an output. And this push button, I don't actually have a push button hooked up right now, so we're gonna ignore that. But we can later we could hook up a push button to see some cooler action going on. So I'm gonna skip over that push button code up there. We're gonna digital write to the LED pin to turn it off. Then we're gonna read the value out of our potentiometer, and we're gonna take that value from our potentiometer and we're gonna write it to the servo. But if you remember, values that we're getting from the potentiometer are between like 60 and some other big number.
700.
60 and 700, right? But the values that we want to write to the arm are only 0 to 179. So we need to scale these 60 to 700 values to 0 to 179. So if you know some algebra, you could do that like just by writing some code. But they have this handy map function that will do just that for you.
Keep you from pulling out a lot of hair.
Yeah. So this is mapping the value that we read from that potentiometer between 60 and 700 to a correlating value between 0 and 179. So we give it the potentiometer and the min-max that we expect from that, and then the min-max that we want to get to the servo, and then we have this value here. It's an integer between 0 and 179. I'm just printing that out to the serial port so we can kind of debug it, and then we're writing that value to the servo. So if this all works correctly, what we should be able to do is turn this dial and see Plex's arm move. And then also if we wanted to monitor that debugging, we can open up the serial monitor. So let's go ahead and upload that sketch, but it's going to give us an error because I have it unplugged. So let's plug in the Arduino.
Rule number 1 of hardware development: things generally do work better when plugged in.
Yeah, it's usually my fault if the program fails, not the Arduino's. But sometimes hardware is broken and could do that. Let's try to upload this again.
And Arduino isn't the only thing in this space. Parallax has what they call the basic stamps, which are much older, have been around for a lot longer. There's a much bigger body of stuff, but they're not open source. The Arduino environment is entirely open source. You can buy the Atmel processors to put on your own boards that you design yourself, and build your own boards. SparkFun has a service they call Batch PCB, and there's other similar services out there that allow you to have your own boards made. It's not the cheapest way to go, but if you're, if you're making a more advanced project, or you make a few of them and stuff like that, you obviously can't give a breadboard to somebody, because the wires are going to fall out and stuff like that. So.
Well, it looks like there's something wrong with this, so, and we're out of time. But afterwards, I'm going to take this Arduino and put it upstairs. There's kind of a commons area for coffee breaks and stuff up there. If any of you guys want to plug it in, play with it, write some of your own programs, you just download the Arduino software and come upstairs and plug it in and play with it. And I'll be there on and off, but if I'm not there, feel free to just play with it. So.
Outstanding, go.
All right, thanks for coming.